So in this video, we're going to evaluate this integral. Whenever you have fractions, first of all, think of finding the derivative over the function itself. So you would think of if you can find the derivative of denominator here. If that works, so the answer will be ln of absolute value of denominator. But in here, if we would like to have the derivative, that would be 4x plus 7, which is not here and cannot be found or built here. So this is not a good way of doing this integral. Now, after that, we are sure we cannot do it with the help of ln from the beginning. So we would think of partial fractions. In order to write this as with the help of partial fractions, we are going to say that 3x plus 2 over 2x squared plus 7x minus 17, we're going to factor out the denominator. If you factor it out, you would have x plus 5 times 2x minus 3. And these are both of degree 1. These are linear, and we cannot reduce them anymore. So we would have two fractions here. The first one, x plus 5, and the second one, 2x minus 3. And the first numerator will be a, and the second one will be b. So it will be 3x minus plus 2 for the left side, and for the right side, if you combine these two, you would have multiplied the first one, the top and bottom, with the factor that it doesn't have, 2x minus 3 here, 2x minus 3 here. Also, for the next one, you would multiply the whole thing by x plus 5 and x plus 5 here. So we wouldn't write the denominators because they are all the same. The numerators will be a times 2x minus 3 plus b times x plus 5. So the left side is still 3x plus 2, and the right side, if you multiply a to 2x minus 3, you would get 2ax minus 3x, and the next one will be bx plus 5b. We're going to factor out the terms that have x. So you would have 2a plus b times x, and the rest, which is negative 3a plus 5b, doesn't have any x or any other variables. So we would consider this as a constant. These two sides are equivalent when 2a plus b is 3, the coefficient of x, both sides will be the same, and the constants will be the same as well. So negative 3a plus 5b will be equal to 2. So you have different options. You can multiply the first one by negative 5, or you can switch the coefficients of 2 and negative 3. Whatever you do, the answer will be a equals 1 and b also 1. We would plug these two back here. So the integral will be equal to a, which is 1 over x plus 5 dx, and b, which is also 1 over 2x minus 3 dx. Now, with the help of partial fractions, we have two new integrals that are easy to solve. So the first one will be ln of x plus 5, the absolute value, and the next one will be ln of the absolute value of 2x minus 3, but something is missing here. If you remember, I told you that whenever you have a fraction, check if you can see that in the table. in here, no, we don't see this in the table. And the next step is if we can have the derivative over the expression itself. For the first one, the derivative of x plus 5 is 1, so we have that, and the answer would be ln of absolute value of the denominator. But for the second one, we don't have the derivative here because the derivative of 2x minus 3 is 2. You have two options. You can say u is 2x minus 3 with the help of substitution. So du will be 2 dx, and rewriting the integral will be 1 over u, and instead of dx, we would have du over 2. So it will be 1 over 2, the integral of 1 over u du. And we know that this one is ln of absolute value u plus c. And we know that u is 2x minus 3 here. And we would add 1 over 2 as the answer. Or you may want to do it faster. You would think of the derivative of 2x minus 3 and you say, I wish I had a 2 here. In order to cancel this 2, I would write 1 over 2 next to it. So this way you built the derivative here, and with the help of 1 over 2, you cancel that. Overall, you didn't change the question, and you would have the same answer. So pick one of them, and this is the way that we solve the question. Next one is this integral. Again, we would think of if we have this in the table, of course not. Can we have the derivative of the denominator here? So if we you can do product rule, or you can multiply them. And if you take derivative, you would have 3x squared minus 6. You don't have that here, and you cannot build that here. Because if somehow you had x squared, you would do something, but not when you don't have that here. So the next option is getting help of partial fraction method. So x minus 1 over x squared times x minus 6 will be two fractions for the first part, x and x squared, a and b here. And one fraction for x minus 6, and here will be c. So we know that if we want to combine them, you would multiply the first one by x and x minus 6. So you would do the same here. For the second one, we already have x squared. So it is enough if we multiply it by x minus 6 here and here. And for the third one, we only need to multiply it by x squared. Altogether, x minus 1, the numerators, we only write the numerators to be easier. We would have a times x minus 6 plus b times x minus 6 plus c x squared. You can distribute, you can factor and set them equal, or you can get help of different points. So if we want to get help of points, we would have that if I plug in 0, left side will be negative 1, and right side we don't have this first expression, we don't have the last one, we only have the middle one, which will be negative 6b. So from here, b would be 1 over 6. Pick another number. I would like to pick 6 because it makes two terms 0. If I plug in 6, the left side will be 5, and the right side, I don't have the first term, I don't have the second term, I only have the last one, which is 36 times c. So c will be 5 over 36. One more. You can pick any number, but I would like to pick 1. I think it is easy. So the left side will be 0, and the right side would be negative 5 times a. If you plug in 1 for x, and the next one will be negative 5 times b, which is 1 over 6, plus 5 over 36, which is c. So it will be a equals negative 5 over 36 because they will cancel each other and you would have the denominator as 36. Okay, let's go back to the integral. That would be rewritten with 3 integrals. The first one is a, which is negative 5 over 36 over x dx, plus the second one will be b, which is 1 over 6 over x squared dx, and the third one will be c, which is 5 over 36 over x minus 6 dx. For the first step, we bring out the numbers. Negative 5 over 36, the integral of 1 over x dx, plus 1 over 6, integral of 1 over x squared dx, and the last one, 5 over 36, integral of 1 over x minus 6 dx. Whenever you have fractions, think of ln. And that works here because we know that the derivative of x is 1, which is on top of that. So ln of absolute value of x plus 1 over 6. But in here, 1 over x squared will be rewritten as x to the power negative 2. And you would add 1 to the power in order to find the answer of the integral. That would be negative 1 over x. Plus 5 over 36, and this one also will be ln of absolute value of x minus 6 and plus c as usual.